In the continuity video, we already discussed how our four categories of functions, algebraic, trigonometric, exponential, and logarithmic, as well as any new function constructed from them, are continuous on their domains. But what if we are interested in finding the limit of a function as x goes to a when a is not in the domain? If a function is not continuous, then that means there are discontinuities. Here are three graphs showing three different types of discontinuities. The first is a removable discontinuity. The second is an infinite discontinuity. And the third are jump discontinuities. We'll go through each one. You will notice that the graph of the first example, the first graph, has a point discontinuity when x is equal to 2. But notice that if we are looking for the limit of f of x, as x goes to 2, then there is indeed a limit. And that is because the limit from the left-hand side equals the right-hand side. The limit as x goes to 2 of this function is 3. Notice that that does not equal the function value. We have a discontinuity. But there is a limit, right, as x goes to 2, and we can find that. The way that we find the limit of a point discontinuity is by, in a sense, removing that point from the graph, or adding that point to the graph. So let's walk through an example. The function for this graph is x squared minus x minus 2 over x minus 2. And we want to take the limit of this function as x goes to 2. Notice that we can factor the numerator. When we factor the numerator, we get x minus 2 times x plus 1. Notice that we have an x minus 2 in the numerator and an x minus 2 in the denominator. We can cancel those out. And the reason for that is because the graph of x minus 2 times x plus 1 over x minus 2 is the same as the graph of x plus 1, but with that discontinuity. So therefore, we can cancel out that x minus 2 on the numerator and the denominator. And it's not because those two functions are equal, but they are equal everywhere but that point. And we know with limits that the function value at that point does not matter. I've already mentioned this, but again, the limit of f of x as x goes to 2 is 3. But the limit of f of x as x goes to 2 does not equal the function value, and so therefore f of x is not continuous at x equals 2, which we already knew. Let's look at the second example. We know that example 2 does not have a limit as x goes to 0, because when we have a limit that goes off to infinity or negative infinity, those can't ever be equal to each other. So let's consider the function 1 over x squared. We already know that the limit as x goes to 0 does not exist, but let's just talk through this. We know that there is no point discontinuity here because we can't factor anything out of the numerator and denominator. We have 1 over x squared. And if there is no point discontinuity, we know we have an infinite discontinuity at x equals 0. And what that means is from the left-hand side and the right-hand side, it either goes up to positive infinity or negative infinity. And the way that we determine this is by reasoning it out. Since x squared is positive if x is less than 0, and also x squared is positive when x is greater than 0, then we know the limit of f of x as x goes to 0 from the left-hand side and the limit of f of x as x goes to 0 from the right-hand side are both infinity, are both positive infinity. Because we cannot have infinity is equal to infinity, our limit does not exist. Let's consider that third graph. The third graph is a little bit different because with a jump discontinuity, you do have a limit existing from one side. So if we consider the limit of this function as x goes to 2, then what we can see is that the limit from the right-hand side as x goes to 2 is 1, and the limit from the left-hand side as x goes to 2 is 0, and those are not equal to each other, so therefore the limit does not exist. So what we've learned through this is that with point discontinuities, we do have a limit, and we can find that by removing this discontinuity, which is basically saying find the equation that is the same graph except at that point, that is continuous at that point. The infinite discontinuities and the jump discontinuities, for different reasons, do not have limits.